Okay, so good afternoon, everyone. As I mentioned, I'm Fernando Gont, Director of Information Security at Juno, and this presentation will be about improving the reaction of IPv6 SLAAC to renumbering events. This is an area where myself and some colleagues have been working for a number of years now to try to to provide a solution for the community. So let's begin with with trying to describe or introduce the problem statement. In order to discuss the problem itself, we first need to do like a super brief introduction or reminder of IPv6 renumbering. Okay. So what is renumbering about? So essentially means that you are going to change the network prefix that you use in your network. Okay, so there are essentially two different ways in which you can do renumbering. The first one is what is normally called planned renumbering. This is something, the meaning of planned renumbering means that you don't try to to change your prefixes from night to date, but it's actually very well planned in advance. And the idea is that for planned renumbering, what you do is you introduce new configuration information, in this case, like the new prefixes. And what you do with your old prefixes is you announce them with decreasing lifetimes. Okay, so the idea is that obviously over time, since you are using decreasing lifetimes, they will eventually expire. Okay, and they will be discarded by all the nodes in your network. The idea here is that before these all is actually becomes invalid, you actually get all of your local hosts to actually discard that information so they don't continue using stale information. So that's planned renumbering, and you could say more or less that planned renumbering is quite well supported by all implementations. Now, there is a different version of renumbering, if you wish, which is flash renumbering. It's not really different in terms of mechanisms, like the protocol features that you use for that, but it is different when it comes to the time constraints or the time frames that are involved when doing these changes. So the idea with flash renumbering is that you want to change your prefix from night to day. So what you want is to completely remove the prefix that you were employing, and at the same time introduce the new prefix that you want to employ. So new configuration information is introduced, and the old configuration, the previous configuration information, is considered instantly to be invalid. Now, the idea here is that to the extent that is possible, of course, what you want to do is to signal that condition to local systems so that they automatically discard, eliminate the stale information that that you are essentially replacing. Okay, the problem here is that part of signaling local nodes that the old information has become invalid may be quite challenging. Among other reasons, there are multiple reasons in there, but among the reasons is that the fact that normally you signal that condition via multicast messages, and at times those messages are maybe unreliable. Okay, so there may be systems that just fail to receive your notifications. There could also be a number of other things, like your network might be partitioned, so your devices were not able to receive your notifications, etc., etc. So in situations where for one reason or another the local systems fail to receive that signal, that notification about information having become stale or old or invalid, if you wish, you may need to have to rely on the default lifetimes that are employed for the local prefixes. The idea here is that since normally all the configuration information that you announce in a network has an associated lifetime, that eventually at some point in time that lifetime value is going to expire, and the corresponding information will be discarded. Now, the problem here is that while at least in theory you could rely on those lifetime values, the problem is that the lifetime values that are employed by the protocol specifications are inappropriate. If you look, for example, at the default lifetime values for the SLAAC prefix information options from RFC 4861, RFC 4861 specifies the preferred lifetime to be 7 days and the valid lifetime to be 30 days. The preferred lifetime, as a reminder, is the period of time, the amount of time that you can use addresses configured for that prefix for new communications. Like if you want to create, let's say, a new TCP connection, then even if you don't hear from the local router for 7 days, you can still use those addresses for creating new connections. But the lifetime, on the other hand, is for how long you can use the prefix, the addresses that you had configured for those prefixes, even if you don't hear from the local router in the meantime. This means that if you have received like a prefix information option with the default values of 7 days for the preferred lifetime and 30 days for the valid lifetime, even if you don't hear from the router again, from the local router again, you will be able to to use the corresponding addresses for 30 days. Okay, obviously this is quite long period of time, and if you were relying on these values to expire in order to for the stale information to be discarded, obviously these long periods of time are unacceptable. So what's the problem statement, or what's the situation that that we have? Flash renumbering events are essentially poorly handled by IPv6 SLAAC. There are even like many engineers in the IETF circles that they argue that, well, they are not even meant to be supported. So if you are experiencing a flash renumbering event, well, by design that's not supposed to be supported, so you are going to face problems. Now, a problem here is that there are some very common network scenarios in which you may experience these flash renumbering events, and as a result of what I just said, the renumbering events, flash renumbering events being poorly handled by IPv6 SLAAC, the lifetime values being too long, etc., you may end up in a situation in which your hosts end up using stale configuration information, like addresses that are no longer valid because the corresponding prefixes, it's not delegated anymore to you. So IPv6 connectivity may fail, and as a result, you might also face a situation where IPv6 traffic may increase. That's considering whether if you're lucky enough that features such as happy eyeballs kick in. So when you try to communicate over IPv6, there's a long, it takes too long to establish let's say a TCP connection, so your system falls back to to trying IPv4 instead. So this is a problem that facing, and it's a problem that we experience nowadays. As I was mentioning before, sometimes the only reason for which you may, let's say, fail to realize that you are experiencing this problem is that, for example, at least for web browsers, if you have a dual stack system, normally web browsers implement, these happy eyeballs, features that I just mentioned. So, while IPv6 connectivity is failing, your device also tries to connect over IPv4, and if IPv4 works, normally you don't care what's the underlying protocol that you are using. Okay, so the internet just works. You don't realize that IPv6 connectivity is failing, and so there's no problem. But as I mentioned before, this problem is quite common, and eventually we will be in a situation where we may want to completely remove IPv4, hopefully at some point, and at that point where we will only be able to rely on IPv6. This is a problem that we will have on the table, and there will be a workaround if we don't do anything about it. So as I mentioned before, there are a number of scenarios, that in which you may experience this problem that I just described. So what I'll do is I will start with probably what's the most common problematic scenario. I will do a more lengthy discussion of it, and then I will briefly also discuss some other common scenarios, maybe not the most obvious ones, but some common scenarios, some other common scenarios where you might, face the same problem. So let's start with the most common IPv6 deployment scenario, which is the scenario that you typically have, for example, in your home network, or even, at times in your, enterprise deployment, okay? So typically what you have is your local network, what we have here in the diagram as the LAN, and you have a customer edge router in the middle of this graphic that essentially communicates with the ISP and also communicates with your local network. These customer edge routers, normally what they do is they employ the Dhcp version 6 prefix delegation to communicate with the ISP, so that, the customer edge router can get a IPv6 prefix list to it, okay? And then what normally happens is that the router will announce on the local network, on the LAN side, a sub-prefix of the prefix that you receive from the ISP side, okay? So customer edge router, it's the interface between the ISP and your, local network. And it typically employs the Dhcp version 6 prefix delegation with the ISP, and normally SLAAC, to communicate or to announce the corresponding information on the local network. Now, let's consider like a super common scenario, which, unfortunately, that's like seems to be the strategy of, of many ISPs, that, whenever you have like, connectivity problems, in many cases, their solution, their approach is like, just, reset your router and the problem will be solved, which at times, it's actually the case. So let's assume, let's suppose for a second that your customer edge router, the customer edge router from the previous slide, is hard reboot. And what I'm meaning with hard reboot is that you just, for example, just press the power button and then you press the power button again, okay? Or just you unplug the router and then you replug the router again. So we are considering the situation where you're not logging into the router and you're not pressing the the reboot button. So what happens in that case? So obviously you reboot your router, you turn it off, and then your customer edge router comes back to life. And normally what happens is that when the device comes back to life, it has no state about the the previously leased prefix. So it has no idea what was the prefix that it was using before. Why? Because in many cases, these devices, they don't have a lot of, stable storage. They have such stable storage just for, storing the configuration information, but not much more than that. So what will normally happen in that, in that case is that your customer edge router will request a new prefix via the Dhcp version 6 prefix delegation to your, okay? And in many cases, your ISP will lease to your customer edge router a new prefix, and this is the prefix that will be employed to announce on the LAN side. Now, a question is, okay, what happened about the old prefix? Okay, so the customer edge router got a new prefix list, but you already have probably a lot of local systems which were which had already configured addresses from the previous prefix. So what will be the scenario, the situation there? Well, most likely your local will still be employing the previous prefix. They may configure, they will most likely configure addresses for the new prefix that has just been announced by the customer edge router, but they will also keep the previous prefix. And why? Because, well, the lifetime values that you were probably using allow them to do so. So there's no reason for them, at least in theory, for them to discard the previous addresses. Now, you might have the question of, okay, so you said, somebody reboot the, customer edge router. So, the customer edge router comes back to life. It does, it requests a new prefix to the ISP and it receives like a new prefix. You might wonder, okay, why did the prefix change? Okay. You might expect that the router, that the ISP just, delegates to you the, leases to you the, the same prefix as before. And there are a number of things going on. This depends on the scenario and depends on a number of factors, but let's just discuss at least some of them. First of all, there are some ISPs that rotate IPv6 prefixes due to privacy considerations. So their take is that, if they always give you the same IPv6 prefix, then the prefix will essentially, identify your home, and then it will be much easier, let's say, for an attacker or, whoever that is, to be able to do network activity correlation, for your communications. So their take is that, from time to time, they want to, to rotate your IPv6 prefix. So at least you don't use the same IPv6 prefix forever. There are other ISPs that, they do exactly the same thing, but, for a different reason. So their take is, and this is like a concept that was borrowed from the IPv4 world, if you wish. So essentially their take is that, well, that of having a stable prefix is kind of like a, premium service. So if you want a stable prefix, well, pay for it. Otherwise, they will, rotate your IPv6 prefix. Whether that should be the case or not, that's a different question. But at the end of the day, it's their business, and they are free to do that kind of stuff. There are other reasons for which you might not get the same, IPv6 prefix as before, even if you desire so. One of the reasons is that there might be cases where the provisioning systems are unable to deliver stable prefixes. That's it. And there are also cases where you might have devices in place that, for example, they get reboot, or they change their state, or there are a number of things that can go on, and they fail to keep state. They fail to keep information about the previously delegated prefixes. Just to throw in an example, let's say that you have your customer edge router, and then you have a number of cascading routers within your home, okay, just to such that you can do like multiple, prefix delegation to, let's say different areas of your home. Maybe your ISP, leases you a stable prefix, but maybe the devices, the routers that you're using internally in your network, they don't keep state about what are the prefixes that they employed, okay? So that will, again, your ISP is providing a stable prefix, but then since your internal devices are not keeping state about what is being used where, you might end up in a situation where your internal systems end up having like dynamic prefixes, if you wish. So the scenario that we just described and which have just discussed is probably the most common scenario where you might, experience these flash renumbering events and the associated connectivity problems. As I mentioned before, if your ISP is providing you with, dual stack connectivity, it could be the case that, normally you're experiencing the problem, or the problem is, taking place, but, since you still have IPv4 there's this, to IPv4 that prevents you from experiencing an actual problem, okay? But in many cases, the problem is there. So let's now just briefly mention some other, common problematic scenarios, okay? So the first one, and this is, you could, deem this as a, let's say, an implementation bug. You could say like an implementation problem. There are, devices like customer edge routers, which are like super simple or too simple actually, where, you have these devices fail to synchronize the SLAAC prefixes that they employ or that they announce on the local network with the Dhcp version 6 prefixes that are released from the ISP. So what happens in many cases is that these devices, they use a constant lifetime when announcing the prefixes on the LAN side without, even caring about what's the lifetime value that is being announced by the ISP, okay, for the prefix delegation. So you might, if you use these devices, you might be in a situation in which the device announced the local prefix with a lifetime that spanned past the lifetime that was allowed by the ISP. So your local devices end up using prefixes that are no longer valid from the point of view of your ISP. There are other things that, might take place in, different kinds of scenarios. Like you could have, like, for example, a virtual machine that is moved from one subnet to another, okay? And if you move the VM and there is no link down, link up event that essentially signals, the VM that, there was a connectivity issue, like the VM was unplugged, so to speak, from the network, then, the VM will detect that, this change, this movement from one subnet to another happened. And what might happen in that case is that it doesn't realize that it needs to reset the network configuration. and it continues using the previous configuration information. It will, of course, normally configure, new addresses for the new prefixes that are unknowns in the new subnet, but the problem there is that it will not be removing the old information. And what happens is that normally the old information is preferred over the new information, okay? And another super common scenario is you may, for example, be running like a common, root advertisement daemon to announce prefix information on the local network. And maybe you just, change the information, you kill the daemon, and you started the daemon again. So there are two things that might have happened. Option one is that the daemon didn't even try to signal the network configuration change on the local network. So it didn't announce the old prefix with a lifetime of 0 to try to invalidate it. Another possibility, if you do things in a better way and the software that you're employing supports it, is that you change the information, okay? The daemon or the software that you are using to announce this information signals that the old information, has become stale and needs to be discarded, but this signal gets lost in the network. There could be multiple reasons. So there could be, in one possible scenario, since this is normally signaled via multicast, and multicast is generally unreliable, maybe the signal was like completely lost, and your local host didn't get that information. There's another possibility. It could happen that, for example, your network gets partitioned for a very short period of time, exactly the moment where this information was sent in the network. So local nodes, fail to receive the notification that they should discard the old information, and since nobody told them to discard that information, they will keep that information and they will use the associated addresses, for as long as the lifetime values allow them to do so. Okay, so these three scenarios, there are more. This is just like examples. These are quite common too, okay? But the reason for which I on the first scenario is because, it's the most common scenario, even, if there's, you're just like a user that, you're not running VMs or anything, just, connecting to the internet with an ISP that provides dual stack service. So there's clearly a problem here. I must say that I know of a lot of people that, not surprises here, they've experienced this problem. In some cases, they don't really know what's the underlying problem, and they learn that they solve the problem, or when they disable IPv6, the problem is solved. So guess what they do? They end up in IPv6. So what we try to do here is to try to avoid that kind of solution, if you wish. So we are going to essentially discuss and briefly evaluate three different areas in which we can do something to try to tackle this problem. Now, the first area is operational mitigations. So this means you are not changing the protocol. You cannot change, for example, the customer edge router, and the only thing that you can do is again apply operation. Could be like, for example, avoiding the use of dynamic prefixes and tweaking the lifetime values so that you use lifetime values that are not so bad. Second option, which you could argue that it's a middle ground between like an operational mitigation and that of completely or changing the protocol to better tackle this problem, is to have your customer edge routers better handle the case of flash renumbering events. So there are a number of things that can be done. Essentially, these are recommendations for customer edge routers, and that is that obviously when this is why these recommendations are widely implemented, it's not that we will completely avoid the problem, but at least the impact of the problem will be smaller. And finally, this is let's say the most correct solution, most complete long-term solution, is to essentially update the SLAAC protocol so that it can more gracefully handle, flash renumbering events. Obviously, typically it takes longer to implement this solution. The reasons everything else, like the operational recommendations and the requirements for customer edge routers, it's something that we have already produced at the IETF. Whereas, the change to the SLAAC protocol is, still ongoing work at the IETF. So it could easily take, at least like a couple of years before we are able to change the protocol implementations, implement this updated behavior, and you have actual products that ship with this, behavior enabled by default. So let's start with the, operational mitigations. There's two different areas, two different things that you might want to do, or that you might be able to do. First one is to avoid the use of dynamic prefixes. So if, for example, you are an ISP and you were, let's say, rotating prefixes, might be intentionally, might not, you might want to reconsider, that option and try to avoid use of dynamic prefixes. Obviously, if the prefix doesn't change, there are, you might avoid this problem altogether, but in specific scenarios. The problem with this is that this will obviously only apply for that specific scenario that we describe of, the typical IPv6 home deployment scenario. But it might not be applicable to other cases. So you might be an ISP and you might say, well, I have a business reason to, to do dynamic prefixes. So that's not an option that I have on the table. So it may or may not, apply to you. And another thing that you could certainly do is to use different values or override the default lifetime values. So you might remember that in one of my past slides, I mentioned that, the specifications state that the default preferred lifetime is 7 days and the default valid lifetime is 30 days. So you could do something like overriding those values and use a preferred lifetime of 45 minutes and using a valid lifetime of 90 minutes. And you might wonder, okay, will this avoid the problem altogether? Obviously not. It will reduce the impact that the problem, has. Obviously, you can be more aggressive, with, how you reduce, these lifetime values. For example, at home, if I remember correctly, I use something like a preferred lifetime of something like, 5 minutes or 10 minutes, and I use a valid lifetime of 15 minutes. Okay. The idea here is that, normally when everything is working okay, these lifetimes get refreshed. Okay. So it doesn't matter if they are short because they will be refreshed if everything is working okay. So again, using more appropriate lifetimes will not avoid the problem, but if you face this problem, at least you won't have to to wait for 30 days for the problem to be resolved. So these two were operational mitigations, if you wish. So let's now jump to the requirement for customer edge routers. So this is work that a couple of colleagues and myself carried out at the IETF. This is published already. It's done. These requirements were specified or documented in RFC 1996. Okay. And in summary, the goal of this document is that it provides recommendations for customer edge routers so that on the one hand, they employ more appropriate lifetimes, similar to what I just discussed in the previous slide. And on the other hand, it provides some recommendations so that some common implementation errors are, avoided. So let's start with the requirements themselves, okay? And let me provide some, some context here too. A number of devices, when you reboot the device, but not like a hard reboot, like, unplugging the device altogether, but when you, go run, get into the device and, press the reboot option, what they do is they send a Dhcp version 6 release message to your ISP, okay? So before rebooting, they send a message to the ISP, essentially saying, I no longer want to use this prefix anymore. So what happens is that obviously, this will introduce by itself, even if your ISP wants to do stable prefixes, if your customer edge router does an explicit Dhcp release message, that will introduce a flash, renumbering event. So the requirement or the advice here is never automatically send the Dhcp version 6 release messages when rebooting. Why? Because that will introduce a flash, renumbering event. And, even if your ISP was using stable prefixes, you will end up facing the problem that we are discussing here. Second one is to do a proper interface between the LAN side and the WAN side. And this is something that I briefly described before. So you have some customer edge routers that, they get a prefix list from the, from the WAN side, from the ISP, and then they use, for example, a constant value for the lifetime value of the prefixes that they announce on the LAN side. So example, you get a prefix list from your ISP and the list time is 4 hours, but then the device announces on the LAN side a lifetime value of 1 month for those corresponding sub-prefixes. So that will obviously mean that eventually, if the prefix changes, the prefix is changed by your ISP, the prefix will expire on the one side, on the one side, but then on the LAN side, the prefix will still be considered valid because, well, the lifetime value allows for that, okay? So the requirement here is, super simple. The lifetimes that you use for prefixes on the LAN side must never span past the, lifetimes that you receive on the WAN side, okay? That's super, logical, but, there are devices that don't implement this. In some cases, it can be because they, they implement the functionality with like 2 different software modules, and they don't interface the 2 software models well. So you have the, the prefix, the software model that you use to, get the prefix list on the one side, and then you just feed a sub prefix to a different module to announce on the LAN side, but there's no let's say that there's no a good interface between the 2 modules. The next piece of advice is kind of like a more general advice than the the previous slide. So in the previous slide, we were focusing on simply on prefixes, on options that are employed to announce prefixes, okay? But normally when you use automatic configuration, it's not just prefixes that, it's not just prefix information that you get from your ISP and that you have to announce on the local network. Simple example, there could be other things. There could be specific routes. There could be DNS server information, okay? So more generally speaking, what we say is that, and this advice also includes the specific case of the prefixes. The idea here is that whenever there is information that you receive on the one side, from your ISP, and, in most cases, there is a lifetime associated with that piece of information. If you have to re-announce, or if you have to announce that information on the, on the LAN side, sorry, you have to make sure that the lifetime that you use on the LAN side never spans past the lifetime that you receive on the one side. That should be obvious, okay? If your ISP tells you, okay, this is DNS information and it's valid only for 4 hours, there's no reason for you to announce it on the one side and say, on the LAN side, sorry, and say, this is valid for 1 month, because your ISP told you, it's valid for 4 hours, not for a month. So this is more, general, if you wish, advice than in the previous slide. The next piece of advice or requirement is that first of all, to the extent that is possible, your customer edge router should try to record the Dhcp version 6 list information on stable storage. And what's the idea here? So if you are able, if your customer edge router is able to store the list information on stable storage, then, for example, if this device is hard reboot, like it's unplugged and then it's replugged again, it may contrast, it may compare the information that it just received from the ISP with the information that was in stable storage. And, based on that comparison, you may detect that there is a flash renumbering event taking place, because you can detect that, the prefix that you're being listed right now is different prefix that you were employing before, okay? Now, if you're able to detect, the flash renumbering event, the next obvious thing that you could do is, announce the the old information on the local network as stale information, or to put things in a different way, besides announcing the new information, you also announce the old information, but with a lifetime of zero, okay? So that you let your local, hosts know that they should be removing that information because it's no longer valid, okay? Now, so the requirement is, if possible, store, Dhcp version 6 least information on stable storage. And if possible, try to detect whenever there is a flash renumbering event and signal that situation, that condition on the LAN side. The problem here is that, as I mentioned before, well, first of all, there are many devices that do not implement this at all. Like, they don't store the least information on stable storage, even if they could. And if they do store that information, they use that information to try to detect flash renumbering events. But that aside, in a lot of cases, the devices that you use for a customer edge router as at home, for example, they could be like a super cheap device that the only stable storage that they have is just for storing the configuration information, but not more than that. So it may or may not be possible to to actually implement this recommendation. Next recommendation for customer edge routers is to employ more appropriate lifetimes. And this is, again, something that, I described before as an operational mitigation, if you wish. So if you look at the recommended SLAAC default lifetimes for, prefixes, the RFC 4861 recommends a preferred lifetime of 7 days and a valid lifetime of 30 days. That's too long. That's super long, too long. So the requirement here for customer edge routers is that they override this default value and they employ a preferred lifetime of 45 minutes and a valid lifetime of 90 minutes. And to be honest, what we have in this recommendation is actually super ultra conservative, and most likely you'd want to reduce these values much further. Okay, but again, this is a committee decision, if you wish. So there was a trade-off here between the values that we authors wanted probably to recommend and the values that would actually flow well within the IETF to be approved. Okay, so that's so far for the recommendations for customer edge routers. Important thing, those recommendations were published already. Okay, so you could direct your vendor, to those recommendations. Now, the final possible solution, which is the most complete solution, most long-term solution, is that of improving the SLAAC protocol. Okay. So I will not get into the details here because it's it's slightly more complex, you could say. But there is ongoing work at the IETF on an internet draft to essentially update the SLAAC protocol so it can more gracefully handle flash renumbering events. And you could say that the goals or the kind of thing that the document tries to do is two things. It's twofold. On one hand, to use, not improve, to use more appropriate lifetimes. That essentially what we have discussed before, as operational mitigations and recommendations for customer edge routers. And the other thing that the document proposes is to implement heuristics to try to detect flash renumbering events on the receiving side. I will not get into I will not get into the details on how this might be done, but essentially you might think about the following. So if you are, for example, a host implementation, okay, and you keep track of what's the information that you receive in router advertisement messages, then you might say, okay, if there was this router, okay, that was advertising this prefix before, okay, and now all out of the sudden, the same router, it is advertising a new prefix, but not the previous prefix, it's super likely that a flash renumbering event has taken place, okay? There are obviously small details in there, so sometimes it's not that straightforward, or it can be that straightforward, but there are some corner cases that the spec currently, allows and supports. And, there are, people that say, well, but, we still need to support those corner cases. And you wonder, okay, but do they have any practice? No, but people still want to support, that corner cases, even if the price to be paid for that is that we experience this problem, like, in very common scenarios. So again, this last option is to improve the SLAAC protocol. So conclusions about this. Essentially, the problems arising from IPv6 flash renumbering events are, quite common. And we originally analyzed this problem and documented it in RFC 8978. Okay, just as an FYI, we tried to do everything at once, like documented, providing the solution, and so on. But there was quite a bit of resistance at the IETF. So what we ended up doing was like, partition the problem. So we started with RFC, 8978. And what we did there is document the problem. And at least, in that way, there would be agreement on, the fact that we had a problem and there was something that, should be done about it. When it comes to the, solution space, there are operational, mitigations. One of them is to tweak the default lifetimes. This is the most general one, right? Because you could argue that you might want to refrain from using dynamic prefixes, but as I mentioned before, there might be multiple reasons for which an ISP is using dynamic prefixes, whether that's a commercial reason or whether it's a different kind of problem, like privacy considerations. There is, in the solution space, as I mentioned before, improved, customer edge router behavior. Okay, this is documented and specified in RFC 1996, and this is super important because if you are an ISP, this is something that you could keep in mind for your RFPs. Okay, so you could, direct your vendor to this document and say, well, next time that I purchase, customer edge routers from you, I would definitely like, this functionality to be implemented. And, finally, as I mentioned before, like the more, let's say, robust long-term solution would be to improve the SLAAC protocol. And, in that regard, there is ongoing work at the IETF in this document, draft IETF 6-man SLAAC renum. And, that last bit of the, the solution space, the improvement of the SLAAC protocol, it's still ongoing work at the IETF. So, my final, let's say, comment or words about this is that there is still work to be done. So, I'm done with the presentation itself. So we have some time for Q&A if you do have like questions. So I guess we can, go to the floor over there or to the studio.